The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more. Over the past 5 years, hail damage has caused more than 50% of total insured project losses for solar farms. So that's a big number. In 2022 alone, hail losses exceeded $300 million in Texas. And the average solar hail claim now amounts to approximately $58 million. So this is a big deal in the insurance industry. And as you mentioned, right, insurance rates are going up. And that's not just in solar. Insurance rates are going up for all kinds of things. Hail impacts all kinds of things.
Are you speeding the energy transition? Here at the Clean Power Hour, our hosts Tim Montague and John Weaver bring you the best in solar, batteries, and clean technologies every week. Want to go deeper into decarbonization? We do too. We're here to help you understand and command the commercial, residential, and utility solar, wind, and storage industries. So let's get to it. Together we can speed the energy transition.
Today on the Clean Power Hour, mitigating the impacts of hail damage on large-scale solar projects in the U.S. My guest today is Senior Principal Engineer with VDE Americas, Jon Previtali. Welcome to the show, John.
Thank you, Tim. Thank you for having me.
Really looking forward to discussing your work on hail damage. Check out all of our content at cleanpowerhour.com. Give us a rating and a review on Apple or Spotify, and please reach out to me on LinkedIn. I love hearing from my listeners. So, John, tell our listeners a little bit about yourself. How long have you been working in the solar industry, and what is it that VDE Americas is best known for?
Sure. Yeah. So, I've been working in solar for over 20 years now. I was actually in the first .com boom of the internet business back in the 90s. So, I did that until the bubble burst, and then, got into solar. And around that time when, most of the solar was residential and CNI, there was really just only a few utility scale projects.
What year was that when you got your first solar work going?
About 2003.
Okay.
2002, 2003. Yeah.
So you must know Mike Hall then, because he was one of the few solar entrepreneurs working in California at that time too.
I'm sorry, who?
Mike Hall of Borrego. Do you know Mike?
I don't know Mike. Yeah, sorry.
Okay. Because you're definitely an early adopter. There are a few people I've interviewed who have been in solar longer than Mike Hall. He got his start in '02. Anyway, okay. I digress. Yeah. Tell us about VDE. What is VDE, and why are we talking about hail damage?
Yeah. So VDE, it stands for Verbund Elektrotechnik in German. And we're actually a 160-year-old company that was founded by Werner von Siemens, who was the Thomas Edison or Nicholas Tesla or Westinghouse of Europe. Siemens built out, organized, and designed and constructed with his team a large portion of the European infrastructure for the grid. And at that time, 160 years ago, as I mentioned, it became clear to him that they needed an organization that was responsible for the safety of the grid. And so he established VDE, which incidentally in German means the Society for Electrical Engineering, and roughly. And so in Europe, VDE is mostly a standards organization and also a safety testing organization. So if you go over to, very much like UL, Underwriters Laboratory. So if you go over to Europe and you turn over like an electronic good, like a retail product, you'll see a VDE stamp to confirm that it's safe to use. But in the United States, we're actually a relatively small group of engineers who are totally focused on solar and energy storage technical due diligence. And we've been doing business in the United States for over 10 years. Our primary client is Wells Fargo. We're essentially the owner's engineering staff for Wells Fargo's tax equity team, and doing that for almost 10 years. And we've worked through them and through other clients. We've worked on about 10 gigawatts of utility scale and CNI and community scale solar power projects that are actually operating in the United States. So not just in the development phase, but in the operating phase. And Wells Fargo is still our top customer, but we also serve a number of developers as independent engineer as well. Yeah, and I worked at Wells on the tax equity team for about 9 years before coming to VDE about 2 years ago. I established and led the technical due diligence practice at Wells Fargo's tax equity group.
Okay, cool. Mm-hmm. 10 gigawatts of solar, you said, huh?
Yeah.
Nice. Well, let's dive into the topic du jour. In 2024, we've had some big hailstorms that impacted projects in places like Texas. The one that was in the news a lot was Fighting Jays. It's a 350 megawatt solar farm in Fort Bend County, Texas. If you just Google that, you'll see that project suffered massive, what we would call catastrophic hail damage. And so as a result, more and more people are thinking about, talking about, and drilling down on how to mitigate against hail damage in large-scale solar. So paint us a picture, Jon, if you would, about what are the considerations for project developers and asset owners when it comes to hail damage?
Yeah, it's a good question. And unfortunately, as I think you alluded to, Fighting Jays is just one of a number of major losses we've had in solar due to hail over the last few years, really starting in 2019 with the Midway solar hail loss, which was estimated to be about $70 million. That's when we saw the hail insurance market, really for all industries, harden, meaning that sublimits were lowered and premiums went up. And so unfortunately now, many times it's hard to make projects pencil with the cost of hail insurance, and oftentimes hail insurance isn't even available for some solar projects. Yeah, so it's a tough problem to solve. I can say personally, I feel like I missed this issue as a technical due diligence expert. We were at that time before Midway, we were building projects outside of Texas in places where there wasn't as much hail risk, like in California, like the Central Valley and whatnot. And then when I saw that Midway disaster, I think is a fair assessment, I immediately took action to try to put into place hail monitoring and stow capabilities for the projects that Wells Fargo was funding in Texas. And the good news is that I was successful we as a team at Wells were successful in doing that with those projects. So it didn't hold up financing for those projects, but it has, this issue has been, needless to say, a major problem for the solar industry that's really limiting the growth of solar, particularly in places like Texas and the Midwest, where we have high hail risk. But there are solutions, and that's what we specialize in helping people find. And the solutions are things
hold on a second. Hold on a sec. I want to put an image on the screen. This is a FEMA map, and I'll put a link in the show notes for audio listeners. But this is showing the hail risk across the U.S., and it's clearly, it's clear that there is a band, right, running down the middle of the country that is very high risk. The red, orange, and yellow that you see on this map is high risk. Well, yellow's relatively moderate. So, but huge swaths of the Great Plains and the Midwest, including Texas, which is a huge solar state, and then, here in the Midwest, Illinois, Indiana, Iowa, Minnesota, Wisconsin is also home to large utility scale solar farms now. So this is a real consideration for solar developers. Just if you're questioning, you may live in a blue state. Okay, on this map, blue is very low risk, including Arizona, Utah, Nevada. Some places are very low risk. So hail is very spotty, so to speak, but there's a huge band across the middle part of the country. So just to set that stage. So
well, let me go back to that map and I'll show you why some of that map is wrong.
Yeah, talk to me about the map.
I mean, this map is directionally correct, but there's so many wrong places in this that mislead people. And unfortunately, FEMA maps, the hail map is not the only one problematic map with FEMA. The flood maps are also wrong. And the reason that is because there's population bias in these maps.
Sure.
You can see that there are some locations where there's very low or relatively low hail risk right next to areas where there's very high and relatively high hail risk. Nature doesn't work like that.
Right.
So the reason that we're seeing this is because this map is based on what's called spotter data and also probably claims, insurance claims.
Yeah.
And spotter data is data that's sent in by storm spotters, basically storm watchers.
That's a great point.
Yeah.
So it's worse. It's probably worse than the map shows, right? There are some blue. There are some blue areas here that should be red or orange, and we just don't have good data.
Frankly, it's a disservice that FEMA is doing to the insurance industry by putting out these inaccurate maps.
Well, some map is better than no map, I would argue.
I agree. And so the reason I'm mentioning this is because we have better maps. So VDE
we being VDE?
Yes.
Okay.
We have better maps. So we have maps that are based on radar data, covers the entire continental US. And do you want me to show you one of the maps?
Yeah, you can put a map on screen, sure.
So we saw this map. This map shows, let's just turn on 45. This map shows the return interval for a 45 millimeter hail or greater hailstorms.
Okay.
And the return interval is the chance of one hailstorm happening within a certain time frame. And so you can see, just with this 45 millimeter layer, there's a 1 in 25 year chance of a hailstorm of that size happening in this entire area of the United States, and 1 in 50 in this orange area. So as I mentioned, while the FEMA map is directionally correct, it's I don't want people to think that there are little spots, of areas that are actually high risk that are magically low risk, because that just doesn't happen.
Sure. And you referenced 45 millimeters, which is 1.7 or 1.8 inches. So, you're talking golf ball sized or maybe a little bigger, right? In the solar industry, we talk about solar panels being designed to withstand golf ball size hail or 1 inch hail maybe, but not larger. And so talk a little bit about that. What are the module manufacturers designing to set the stage a little better as well? And then maybe you could just go ahead and close your map unless you wanted to talk more about the map.
I'll stop sharing. Well, I do want to mention just real quickly, the other thing that we have in these maps that we can show are actually average annual loss and probable maximum loss for different types of modules. So for solar, series 6 and 7, 2 millimeter glass, 3.2 millimeter front glass polymer backsheet, and then also at different tracker angles into the wind and away from the wind. So these maps are really good for developers who are trying to understand the risk of hail with specific modules and specific tracker capabilities at specific locations during the siting process or procurement process. So these are all available on the Esri ArcGIS website, by the way. So about, you mentioned that module manufacturers design modules with specific hail resiliencies. And, that claim is, they do make those claims. And you can see in the data sheet oftentimes that they have hail resiliency up to, the most common is 25 millimeters.
Okay.
Right. Some have testing up to 35 millimeters. But the issue with that is that, first of all, we're seeing hail that's like much larger than that. We're seeing hail. I was just I just did an analysis for SIA. Our team did an analysis for SIA looking at historical hail at projects over 50 megawatts. And there were dozens of projects that have experienced hail way greater than 45 millimeters, like 65 millimeters, 70 millimeters. So that's the first issue, is that we're actually seeing much larger hail than these modules are designed for. And then the other issue is that the actual testing that's done on these modules is not sufficient. It's not a test to failure. They get a couple modules, they send them to a test lab like our sister company, RETC, who does a good job testing to the IEC standard, which governs this hail test. They shoot a couple 25 millimeter or 35 millimeter freezer ice balls onto these modules. And if they don't break, then they're good to go. But unfortunately, they're only testing a couple samples, right? And as I mentioned, they're not testing to failure. So we actually don't have a good way of creating an accurate hail resiliency curve for these modules. And so one of the things that we're doing, actually in collaboration with RETC, is we're developing a better hail test that actually uses freezer ice balls, which are a proxy for hail, for naturally occurring hail, over a larger range of sizes, representing a larger number of impact energies. So impacts at different, you can model different angles with different impact energies, right? So we really understand the true hail resilience of modules using this new test of failure.
Okay.
It's going to be ready in a couple months.
But so what is so different about the test that you've developed compared to others?
Oh, the other thing I'll mention, yeah. So instead of using a couple modules, we're using 30 modules. So it accounts for a diversity in the glass manufacturing. We are seeing glass defects from time to time that seem to affect hail resiliency. So in addition to being able to create a much more accurate hail resiliency curve with more hail impacts that are essentially a test to failure, we're actually using 30 different modules for this. And so we can account for variation in the module.
And in terms of resistance to hail, I think about two things. There's the module itself and the thickness of the glass. And as you pointed out, there's different thicknesses, and we can get into that, why there's different thicknesses. And there's different angles, right? Flat roof solar for commercial solar is typically 10 degrees. And then you have sloped roof, of course, which is at whatever angle the roof is. And then you have fixed tilt ground mount, which is often at 30 degrees or 20 degrees. And then you have trackers. For large scale solar, the statistic I've learned is 96% of ground mount solar is using single axis trackers. And it's noteworthy that when you Google fighting jays, hail damage, there's a story in PV Tech about Array Technologies, the tracker manufacturer, developing a hail tracking software. So obviously there are things you can do with the angle of the Array with trackers, and we're going to get into this. The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more. But what do you want to convey about module construction or design? And then let's talk about racking and trackers.
Yeah. So yeah, the module makes a difference. 2 millimeter front glass, back glass, bifacial modules are about half as resistant to hail, as resilient to hail as 3.2 millimeter front glass modules with polymer backsheet. And the reason that is because the 2 millimeter thin glass is not fully heat tempered in like the vast majority of manufacturing scenarios. And while 3.2 millimeter is, so it's just much easier to fully heat temper 3.2 millimeter front glass. So it's actually a harder glass. So you really see less damage with 3.2 millimeter front glass than you do with 2 millimeter glass modules due to hail. But to your point though, the tracker angle also makes a huge difference. So really the steeper the angle, the better to a certain degree. You don't want something that's so steep that it's going to catch more hail because of the wind. Wind makes a big difference too. So, and it's difficult to predict the wind speed and the direction when hail hits. But in general, the steeper the angle, the better. The other thing I'll mention is that if you can put the trackers into an angle away from the wind, facing away from the wind, that's better than facing them into the wind. So we recommend actually a two-pronged approach to hail monitoring and stow. And the first prong is what we call preemptive stow. And this was really, I would say, pioneered by Kevin Christie at Lightsource BP. And the idea is that the operator will monitor for severe convective storms that may contain hail just in the region around the project. And if they start getting an alert for a storm like that, the day before or hours before, we recommend that the operator put the trackers into a preemptive stow position facing away from the prevailing wind direction, so the direction of the storm at the steepest angle.
And that's a little counterintuitive because you're also thinking, well, if you put the back of the array towards the wind, then it's going to catch more wind and potentially face wind damage, right? Because the modules also crack when you dig into this problem. Very thin glass, 2 millimeter glass, is very prevalent on bifacial modules. Bifacial modules have swept the large scale solar industry now. I don't know what the percentage is, but it's very high. And if you again Google this problem, but go to PV Magazine, they've got stories on this that just out of the box you're getting 10% breakage oftentimes because the glass is so thin. These are very fragile now. And so talk about that, because you're optimizing around multiple variables now.
Yeah, that's a good point. Yeah, no, we haven't seen that type of glass breakage due to high winds. Actually, the glass breakage that you're talking about seems to be due to defects or issues with the design of the connection between the torque tube and the modules. There's a bracket, but then there's a rail that is supposed to be installed around the outer rows, the perimeter rows of the array, that basically stiffens the module. So
the rail is being installed in the middle along the portrait length of the module. Is that correct?
Yeah, that's right. Yeah. But if there aren't enough modules with that rail, then you are going to have some breakage. But also, as I mentioned, they're most likely glass defects that are also causing that issue. So back to your original question, we think that the risk of hail damage is much greater than the risk of wind damage. And so that's why we're recommending that modules
in certain geographies where you have hail. Not everywhere has hail.
Fair enough. Yeah.
So how big is this problem for the industry writ large? Like, how do you see this problem?
Oh, it's a huge problem. It's a huge problem that we missed, that I personally missed and lots of people missed years ago. And part of the reason we missed it is just we got overconfident, comfortable or whatnot, because insurance was cheap and reliable, right? And you didn't have scenarios where it was not renewed on a yearly basis, right? Which is, starting to happen now, right? And so we thought, okay, we knew that there was some level of hail risk, but we didn't bother to really assess it. Whatever before 2019, we didn't bother to really understand, like quantify the risk of average annual loss or probable maximum loss or whatnot. We just relied on insurance. So we got soft.
And for my listeners, a quick tool to use to study this problem is a platform called Perplexity. It's a large language model, perplexity.ai. But what I like about Perplexity is it gives you references to the information that it's sourcing. And so I just asked Perplexity, how prevalent is hail damage in solar farms? And it gives me some answers. It says over the past 5 years, hail damage has caused more than 50% of total insured project losses for solar farms. So that's a big number. In 2022 alone, hail losses exceeded $300 million in Texas. And the average solar hail claim now amounts to approximately $58 million. So this is a big deal in the insurance industry. And as you mentioned, right, insurance rates are going up. And that's not just in solar. Insurance rates are going up for all kinds of things. Hail impacts all kinds of things, roofs, cars, buildings, etc., right? But so yes, it's a growing problem and a problem that we need to pay more attention to, and it has real economic impacts on our industry and on the insurance industry. And you also mentioned that some projects can no longer get hail insurance. If you're a project developer and asset owner, what are you thinking about and what are you trying to do to ensure that your project is insurable?
Yeah, it's a really good question. So obviously you're shopping around like you would normally do, regardless of whether we had this problem or not. And, specifically, I would say developers, owners, operators are looking for insurance providers that take into account, proven hail monitoring and stow capabilities, right? So we're at a point where I would say it's fair to say the insurance industry and the solar industry are believing the analyses that VDE Americas is putting out there with regard to hail risk. Okay. Just like I mentioned, the average annual losses, the probable maximum losses with different module and tracker configurations at different locations. So they believe the analyses, and we validated those analyses, and they look good. So that's like the next phase, I would say, in convincing the insurance industry that we are on top of this problem and that we're solving this problem, is proving to them that the hail monitoring and stow protocols are in place, right? Mm-hmm. And so we actually are now helping customers do that. We have a best practices memo that's free from our website that we recently co-published with Wells Fargo, who I mentioned is our primary customer. And then we also have a hail stow protocol, off-the-shelf hail stow protocol testing and forensics specification, like a forensics protocol specification that we can provide customers. But it's super important. I would say that it's super important to have this stuff documented, right? So people who are monitoring for hail know what to do when hail is approaching, using this two-pronged approach that I started to talk about before, preemptive stow, and then basically immediate stow. If you miss the preemptive stow window, it's so important to have an alert from a reliable hail monitoring service, mm-hmm. Like DTN. We think DTN is the best, and that will come in ample time to put the trackers into a hail stow position.
So walk us through some of the mechanics of that.
Yeah.
Okay, you've got your solar array. It's got a SCADA system monitoring what's going on with production, but there's this whole other world of what's going on in the environment. When is the storm coming? How does DTN work if you're an asset manager?
Yeah. It's not a perfect system because, hailstorms can form very close to project perimeters and even over the projects, right? But basically there's a national radar system out there called NEXRAD that's maintained by the federal government through NOAA and the National Weather Service. And that monitors for hail, and that provides basically near real-time data that companies like DTN translate into these things called storm corridors, which are essentially like these digital polygons that track storms, and they can tell what the probability of hail of different sizes is within these storm corridors and which direction these hailstorms are moving. And so what you can do is you can set up, an alerting service to alert at a certain perimeter, a certain radius beyond the project's perimeter. We recommend 30 miles, right? At least 30 miles to get a hail alert. And the reason that is because hailstorms can travel up to 60 miles per hour. So we want to give operators ample time to put the trackers into stow position. We think 30 minutes is probably ample time typically. Yeah.
Yeah, I'm at the DTN website, and what one of the things I immediately think of, John, is you're going to preemptively stow your project, meaning tip it up to 60 degrees. Is that right?
Yeah, depending on the tracker. Array Technologies is 52 degrees, but yeah, tip it to the maximum tilt angle.
So 50 plus degrees. And then you're going, well, Tim, but I'm going to lose my production. And yes, you are going to lose your production if it's the middle of the day and the tracker should be pointing straight up, let's say at high noon, right? And obviously you want to minimize the impact of the hail. So you're going to hail stow at a high angle. And interestingly, though, DTN found that, one study showed moving into hail stow during extreme weather events resulted in a production loss of $12,000 and a property insurance premium reduction of $2 million per year. So the loss in energy is trivial relative to the gain in cheaper premium. And you also then have to think about the cost of a loss event, of a catastrophic event. So that's right.
Could I just chime in on that?
Go ahead.
So basically the reason that is because when you have hailstorms approaching, you almost always have cloudy skies anyway, right? You have overcast skies. So your energy production is going to already be very low.
Yeah.
In fact, in speaking with LightSource BP, they've said that their asset managers they haven't even noticed when the trackers are being put into hail stow relative to the expected performance. And then there's also there was a really good poster at the PVRW conference a couple of years ago by Nicole Thompson at WH Analytics that basically demonstrated what I'm talking about. And I'll just take an opportunity to mention that KWH Analytics sells insurance, and they are one of the few insurance companies that actually take hail monitoring and stow protocols into account when they're pricing insurance.
Very cool. So in our last couple of minutes together, John, you have been working on a tech memo on this topic. We will put a link to that memo, which is going to be in the wild by the time this publishes. But give us a quick summary of what you found in doing this research.
Yeah, this is interesting. So this is actually the second tech memo on hail that we are going to publish with a client. And the first tech memo, I think I mentioned before, was with Wells Fargo, and it describes the best practices that we in Wells Fargo think should be used for hail monitoring and stow. And now this next memo, and I guess I could mention the customer. It's with Array Technologies, because by the time this is aired, the memo is going to be out. It shows the effectiveness of hail stow. So we looked at 3 projects that were in a close vicinity and within 15 kilometers of Fighting Jays in March 2016 that experienced similar hail as Fighting Jays, but had no damage because those projects went into hail stow. So very interesting validation of the capabilities of hail stow. There was one project I should mention that there were a couple tracker motors that didn't function properly. We don't know why, but there were a few rows that did not go into hail stow, and those did have damage. And so it was actually a very good proof point to demonstrate that hail stow did work for all the rest of the trackers on that site that went into hail stow. So it's a validation study of hail monitoring and stow.
Sure. Yeah. And, this isn't rocket science. It makes a lot of sense that if you put the tracker at a higher angle, you're avoiding that direct hit, so to speak, that's going to be the highest risk factor. But now you're putting some some concrete engineering
Yeah.
and statistical analysis behind this. So that's cool. Are the tracker manufacturers responding to this? Because there's obviously credible evidence that they need to have a hail stow and then a way to effectively automate putting the array in hail stow.
Yeah, we're seeing some really good responses from tracker manufacturers. So yeah, we're working with we're working with all the leading tracker manufacturers in the United States. And yeah, so you can see that, they're developing, first of all, ways to manually put their trackers into hail stow much more quickly than ever before. A few years ago, we would have scenarios where the operators had to go to each tracker controller and put it into hail stow separately across the entire array field, and it would just take hours, right? So now we have like a one button. We have these tracker stow interfaces that have one button hail stow capabilities, which is great. They're also integrating hail monitoring services, and they're also starting to offer automated hail stow capabilities, which is great because you take the operator out of it. I wouldn't say that people should rely entirely on automated stow. We still think that having an operator monitoring for hail and putting the trackers into hail stow preemptively is really good, but having an automated hail stow capability is really good as well.
All right. Well, check out all of our content at cleanpowerhour.com. Please give us a rating and a review on Apple and Spotify. That is the best way you can help others find this content. And reach out to me on LinkedIn. I love hearing from my listeners, or you can contact me via the website, cleanpowerhour.com. Jon, how can our listeners find you?
Oh, yeah. They can easily go to my website or our website, VDE Americas, or they can contact me through LinkedIn.
Very good. Well, thank you so much, Jon Previtali at VDE Americas, for joining us on this interesting and important topic, how to mitigate hail damage in large-scale solar. I'm Tim Montague. Let's grow solar and storage. Take care, Jon. The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more.